welcome back to the deep dive. Okay, let's unpack something pretty unsettling today. Imagine this, a security flaw. So sneaky it can infect, get this, 95% of computers before your operating system even loads.
That's a staggering number.
It really is. And the kicker, you'd likely never even know it happened. This vulnerability, it actually has a name, logo fail.
Yeah.
And believe it or not, it exploits something we see every single day, something seemingly harmless, that brand logo that pops up when you start your machine.
You mean like the Windows logo or Dell or Acer?
Exactly. That little bit of branding, suddenly that's become, well, a potential backdoor, a serious one.
Yeah.
So in this deep dive, our mission is really to understand what makes logo fails so treacherous. We need to look at how a computer should boot up securely.
Right, the normal process.
And then crucially, figure out why on earth a simple logo could become this major entry point for an attacker.
Yeah.
Get ready for some real aha moments here, I think. So let's just dive right in. What exactly is this logo fail?
Well, logo fail, as you said, it leverages that seemingly harmless display of the manufacturer's logo during the boot up. It specifically targets flaws within the code that's designed just to load and show those images. And the real danger, the truly significant threat here, is that any attack that happens before your main operating system loads, well, it can become virtually undetectable.
Undetectable by normal security software.
Exactly. Think about it. Your antivirus, your security suites, they only start running after the operating system is up and running. If something compromises the system before that,
It's already too late.
pretty much. And here's where it gets really fascinating in a scary way. Picture this. Malicious code gets loaded super early in the boot sequence, way before Windows or Linux or Mac OS really takes control. Now, this code doesn't just execute and stop. It actually creates a virtual machine, sort of like a computer running inside your computer.
Okay.
And then your actual operating system, your Windows, your Linux, it gets loaded and runs inside this malicious virtual machine.
Wait, so to me, the user, it would look normal.
Completely normal. You power on, you see the logo, your OS loads, you log in, use your apps.
Yeah.
Everything seems fine. Modern processors are so powerful you likely wouldn't even notice a performance hit.
Oh.
But here's the thing. If you run an antivirus scan, it finds absolutely nothing because the antivirus itself is running inside that virtualized OS.
Which is inside the compromised machine.
Precisely. It's completely sandboxed from the real threat. So that hidden malicious layer, it can capture everything. Your keystrokes, sensitive data, logins, you name it, all without you having any way to detect it or, frankly, protect yourself effectively once it's there.
Yeah.
It's a really deep system compromise.
So yeah, that's mind-bending stealth.
Yeah.
So, okay, if an attacker can basically create this shadow system underneath everything, it makes you wonder, how should a computer normally start up? What's this boot process that we usually just ignore?
That's exactly the right question. So normally when you hit that power button, your computer's main memory, the RAM, it's empty. The hard drive hasn't spun up yet properly. The very, very first instructions come from firmware.
Firmware, like
Well,
the BIOS.
Exactly. The BIOS, or on most modern machines, it's actually UEFI, the Unified Extensible Firmware Interface. It's basically the successor to BIOS, more advanced, but a similar idea. It's code stored on a chip on your motherboard.
And that's usually read-only, right?
Well, traditionally ROM, read-only memory, yes. But
Yeah.
these days it can be updated. That's what flashing the BIOS or flashing the firmware is all about. It's not straightforward, but it's definitely possible to reprogram these chips.
Okay, so from that initial BIOS or UEFI code, we kick off what's called the boot chain. Think of it like a relay race.
Okay.
The BIOS UEFI loads a tiny, tiny program, often from the very first sector of your hard drive. This little program's job is just to load a slightly bigger, more complex program.
Which then loads another one.
Got it. It continues in stages, each one loading the next slightly bigger piece until finally your full operating system, Windows, Linux, whatever, gets loaded into RAM.
What? So many steps. Why not just load the OS directly? Because those very first programs have to be incredibly small. They need to fit into really limited memory spaces available right at the start. It's a constraint from the hardware level. This same basic process happens on your smartphone too, by the way.
Right, right.
Now, the critical part for security in this whole boot chain is digital signatures. Or at least that's how it should work, ideally.
Digital signatures,
Mm-hmm.
like verifying authenticity.
Exactly. Each stage in that chain is supposed to check the digital signature of the next stage before it hands over control. If the signature is invalid or if it looks like it's been tampered with,
the whole process stops.
They should abort immediately.
Yeah.
Yeah. That's a fundamental security measure designed specifically to stop attackers from just swapping out one of those early boot programs with their own malicious code. This whole process has been attacked so many times over the years that it's generally become quite robust.
Okay, that makes sense. A chain of trust,
A
basically.
chain of trust, precisely.
But
Yeah.
if it was already so secure, with these signatures and checks,
Yeah.
why did manufacturers decide to stick a logo in there? Where does that fit in?
Yeah, that's the million-dollar question, isn't it? It really comes down to user experience, believe it or not. That whole boot process, checking memory, initializing hardware, loading those stages, it takes a bit of time.
Right, you see the black screen with text sometimes, or just waiting.
Exactly. So manufacturers thought, there's this little delay here. Instead of a blank screen, let's make it look nicer. Let's put our brand logo up. I put my Dell logo here or an Acer logo.
So purely cosmetic.
Essentially, yes.
Yeah.
Fill the perceived dead air, make the startup feel a bit more polished. And here is where it all goes sideways. It turns out vulnerabilities were discovered precisely in the code responsible for loading and displaying that logo.
Not in the main boot sequence, but in the logo loading part.
Correct. That logo image has to be stored somewhere accessible really early on, so it's usually within the firmware itself, the BIOS or UEFI. And apparently, at the exact moment the system reads these image files to splash the logo on your screen, there are flaws in how it parses that image data.
Image parsing, like how it understands the picture file.
Exactly. Flaws in that process can be exploited to basically hijack the execution flow. Instead of just showing a picture, an attacker can make it run arbitrary code.
Ooh.
And that malicious code can then just abort the normal secure boot process and kick off something else entirely, like creating that hidden virtual machine we talked about earlier.
So the cosmetic feature created the security hole.
That's the irony, isn't it? Something added for looks introduces a way to bypass all those security measures built into the actual boot process.
This sounds, utterly devastating. He said 95% of computers are susceptible. That number is just staggering. So is my computer likely hacked right now? What does this mean for, everyday people?
Okay, that reaction is totally understandable. It sounds terrifying. But let's maybe take a slight step back on the immediate panic level. The difficulty of actually pulling off this attack is quite high.
Right, you mentioned that.
Yes, while a huge percentage of machines might have the potential vulnerability in their firmware, an attacker needs one of two things. Either direct physical access to your machine.
Like sitting down at my keyboard.
Yes. Or they need the ability to remotely perform a flash of the BIOS or firmware. And that's the tricky part.
What does flashing the BIOS actually involve? Is that easy?
Oh, far from it. It's definitely not easy. First off, the attacker usually needs administrator rights on your machine already.
So they'd have to compromise it in some other way first.
Often, yes. Or have physical access where they can bypass normal login. Then you typically have to boot the computer into a special mode just to run the BIOS update utility. It's not something that just happens in the background while you're checking email.
So it's not like clicking a bad link could install this.
Generally, no. This isn't that kind of attack vector. The demonstrations we've seen are proofs of concept. They show it can be done under specific conditions. In the example researchers showed, it involved restarting the computer, booting into a special environment, running the firmware update tool with a modified file, and then on the next boot, the malicious code ran.
And what did the code do in their test?
In their public demo, it just created a simple file on the C drive just to prove it executed. But, as we discussed, it could be programmed to do much more, like install that VM hypervisor layer.
Okay, so it's complex. It requires high privileges or physical access. That's somewhat reassuring.
It puts it in perspective, yes. Think of flashing the BIOS like, performing open heart surgery on your computer's core programming. It's delicate, requires specific tools and access, and it's not something attackers can do casually or remotely on a massive scale easily. So while 95% might be technically vulnerable, the actual attack surface is much smaller.
But what if you are targeted? Maybe someone with resources or someone who gets physical access.
Right. And that's where the other shoe drops. The really significant concern for, say, an individual user or even many organizations is the difficulty of detection.
So if it does happen.
If it does happen, the average user has almost no way of knowing. Seriously, how would you check? You'd need to somehow verify the exact version of your BIOS firmware, then perform a cryptographic checksum on it.
A checksum. Like a fingerprint for the file.
Exactly. To see if it matches the official untampered version from the manufacturer, you'd have to know where to get that official version, how to calculate the checksum on your own machine's firmware. It's incredibly difficult for anyone who isn't a security professional.
So it's absurdly hard to check.
Pretty much. So the good news, it's hard to get attacked this way. The bad news, if you are one of the unlucky few, you genuinely wouldn't know without some very specialized investigation.
So connecting all these dots, it really is almost unbelievable, isn't it? That something so, well, cosmetic, just a logo on the screen, could potentially open up such a deep and crucially undetectable security hole. It really makes you question things, doesn't it? Like, how far does this pursuit of a good user experience or just, a pretty visual go? Can it actually compromise the fundamental security of our tech? Right down in those layers we never even think
It
about.
absolutely does. It's a really powerful reflection on just how complex these modern systems are. And, the constant tightrope walk developers face balancing features, usability, aesthetics, and fundamental security.
Yeah.
Because at the end of the day, who would honestly suspect that a simple brand logo could be masking such a potentially huge security flaw? It shows how vulnerabilities can hide in the most unexpected places.
It's definitely something to ponder next time we power on our machines, isn't it? Yeah. So, thinking about all this, what was the most surprising element for you in this whole logo fail situation?
For me, I think it's the sheer elegance of the potential attack, hiding the entire operating system inside a VM. That level of stealth is, well, it's both impressive and deeply concerning.
Yeah, agreed. Okay, well, if this deep dive into logo fail has given you something to think about, maybe even a touch of healthy paranoia, please share it with someone you think needs to hear it. Knowing about these things is the first step. And if you enjoyed this conversation and want more deep dives into these often hidden layers of technology and security, definitely hit that subscribe button.
Yeah, and click the notification bell so you don't miss our next exploration.
Absolutely. Sharing this also really helps us get these important topics out to more people. Your support makes a huge difference. So until next time, keep questioning what lies beneath the surface. This has been The Deep Dive.
Inscreva-se no canal Lau Geek e clique no sininho para não perder nenhuma novidade.